Trigonometry, Lesson 2. Hi, Priyanshi, how are you doing?
I'm doing well, thank you. What about you?
Very good, very good. So, today is our second lesson on trigonometry. I thought let's record these lessons since the first one went so well.
Mhm.
And this should help many of our viewers to understand what is trigonometry and how to begin with it. So, I'd like you to introduce yourself first and then we'll begin with our lesson.
Yeah, okay. My name is Priyanshi. I live in Jersey, which is a small channel island, which is part of England, and I study maths at GCSE level.
Great. Trigonometry is one of the hardest subject in GCSE level. So, in the first class, can you kind of give me a summary of what did you learn?
Well, I can summarize what we did into five main points.
Okay,
First of all, we did a Pythagoras theorem review. So a squared plus b squared is equal to c squared.
yes,
Then we started off by looking at the primary trigonometric ratios,
correct,
which was quite interesting. I got to know that there are three main primary ratios: sine, cosine, and tangent.
correct,
And we also learned how to label the sides. It is all dependent on which angle is theta. So we've got adjacent, opposite, and the longest side, which is the hypotenuse.
correct.
We also learned about a short acronym, so
Mm-hmm,
COTOA.
mm-hmm.
So sines equal to opposite over hypotenuse. So that's so. Ka is equal to cosine is equal to adjacent over hypotenuse, and TOA, which is tangent, is equal to opposite over adjacent.
Correct,
Then we learned about some special triangles.
correct,
So we had the isosceles, which had two of the same sides, so A and A. And when we tried Pythagoras on it, so A squared plus A squared square rooted, we got 2A squared square rooted, which is just A root 2.
correct.
Then we looked at the 30, 60, 90 triangle, which is
Correct.
really interesting as well. So the hypotenuse is double the adjacent side.
Correct.
Using that, we can find out many things, and we through that we also found out some co-function identities.
Correct.
And I also learned that tan theta is equal to sine theta over cos theta.
Excellent. Excellent.
Yeah.
So, perfect. That's all we learned in our last lesson, and let's continue from here. So, I'll share with you a whiteboard and then we'll begin. So, can you see my whiteboard?
Yep, this is perfect.
Great. So let me just recap what you said just now. And one of the few things was SOHCAHTOA you talked about, right? So sine is the ratio of opposite side over hypotenuse. Cosine is the ratio of adjacent to hypotenuse. And tangent is the ratio of opposite to adjacent side.
Mhm.
What we are talking about is really a right triangle, right? So let me just sketch one here for you. So this is the right angle triangle. And normally, what we should do is make this clear, absolutely clear. And let me label this as ABC. So I prefer to label counterclockwise. So A, B, and C. The ratios of the sides which we're talking about. So if I see this angle, let me call this angle as theta for us, right? So
Mhm.
from this angle, the side which we look at is this is the one, which is the opposite side, right?
Yeah.
And this side is adjacent. Adjacent to angle and the degree, 90 degrees. And longest side is, of course, the hypotenuse. Perfect. So sine is the ratio of AC over AB, cosine is BC over AB, and tan is AC over BC. You're correct.
Mhm.
Now, another thing which you referred to was Pythagorean's theorem, which is a square plus b square is c square. We might use it to solve triangles. So a lowercase a, right? So these sides are put opposite to the vertex definition, and that is how we label them, right? So this is standard way of labeling, right? And you also talked about special triangles, right? So let me also draw these special triangles here. One was isosceles triangle. So two sides, which are the legs, are equal. So let's say they are equal, A and A. Again, it's a right angle triangle. Each side, therefore, will be half of 90, right? So 45 degrees. So you'll see a square plus a square is 2a square, and when you square root it, you get a square root 2. Right. And the second important triangle for us is 30, 60, 90. In this case, you notice that one hypotenuse is twice the smallest side, right?
Mhm.
The angle here should be 60 degrees. The other one is 30 degrees. And this one is square root 3 times a, right? So that is how these three sides are related in a 30, 60, 90 triangle. So my suggestion is for all the beginners, when you begin with, that should be your page on the left hand side, which can be referred to as we move along. Perfect.
Yep.
So now the first example here is to calculate the trigonometric ratios, the primary trigonometric ratios from the given triangle. So here is your first triangle. You may have to use calculator for these calculations. So,
Mhm.
Priyanshi, I'd like you to be ready with the calculator and answer my questions. Let us say this particular angle here is 40 degrees. And what we're talking about is a right angle triangle. So, if I label this as A, B, C, can you first tell me what is angle A equals to?
Well, angles in a triangle sum up to 180 degrees. So I know that we have 40 degrees and 90 degrees.
Yes,
So we just add those together to get 130 degrees, and angle A is 50 degrees.
perfect. So we get angle A as 50 degrees. So a shortcut to what you were saying is that in any right angle triangle, the other two smaller angles add
Also add up to
90.
90.
Right.
Yeah.
So the easy thing for anybody who was watching my videos is that angle B plus angle A should be 90 degrees. Since we already have 90 degrees right there in a right angle triangle we're talking about, correct? So,
Hmm.
so it is faster calculation, and therefore we came up with A as 50 degrees. Now, in this particular triangle, I want you to tell me what is sine of 40 degrees.
Sine of 40 degrees. Well, I know that sine is equal to opposite over hypotenuse, and therefore AC over um opposite
But I have not given you any sides, and therefore I would like you to now use calculator to find the values. Can you
of
please
the
use
sides.
calculator? Yes, sine 40 degrees.
Oh yeah.
What do you get?
Sine 40 is equal to 0.64278760097. But
So
we
we'll
could write,
round it to 643.
yeah,
Is it okay? So
yeah, that's,
rounding to 643 means three significant figures. You get the whole idea, right?
yeah.
So we are giving this value to three significant figures, 0.643 units, right? Now, if sine 40 degrees is 643, and let's say The hypotenuse is only 1. In that case, the opposite side should be 0.643, correct? Does it make sense to you?
That's correct, yeah.
So we have worked backwards. That is, if we know the angle, we can find the sides. Right? This was not possible so far without trigonometry. Do you see the whole advantage? Correct.
Hmm.
Now, to get the side BC, what you could do is definitely apply the Pythagorean theorem, which is also said as Pythagoras theorem, and find the length of BC, right? Which is 1 square minus 0.643 whole square square root, right? But
Hmm.
we are going to use again trigonometry. So see how easy it becomes. Can you please find what is cos of 40 degrees?
Cos of 40 degrees is 0.76623 significant figures.
0.766. You get the whole idea, right? So
Yeah, yeah.
what we did is assuming that the hypotenuse is only 1 unit, right? In that case, the other two sides should be 0.643 as the opposite of 40 degrees and 0.766 as the adjacent side of this particular triangle. Does it make sense to you?
That makes sense.
Correct. Now, I'd like you to verify, does it satisfy Pythagorean theorem? That is, how will you verify? Tell me.
Well, I know the c squared is just going to be 1. So what I would do is 0.643 squared plus 0.766 squared square rooted.
Do it and check. What do you get? The internet is very slow, and therefore, when I write, it's not very clear. But I hope still you can see it. Okay, I'm sorry for that. Yeah, so when you do the square and add them up, what do you get?
I get a 1.00010249.5. But if we round it to like three significant figures, we do get 1. So
Which is indeed 1. And therefore, all the calculations which we did are perfect. Do you see how easy it became? Knowing the angle and then figuring out the sides of the triangle has been done for the first time after learning trigonometry. Do you see that? How beautiful it is, correct?
yeah.
So that is one way how we can use trigonometry and our learning. Okay, great. So let's take another example. Again. So this time I'm going to take a very special triangle because it makes things very simple, and that's why these are special. So we are going to take triangle with side 60 degrees, I mean angle 60 degrees, and of course 30 as the other one, 90. And now if I place hypotenuse as let's say 10, in that case, can you tell me? Let me just label it as PQR, okay?
Mhm.
PQR. So it is not necessary to always label the triangle as ABC, right? It could be anything you like. Okay, great. So now, if I know that PQ is 10, what is QR?
Well, I know that this is a 30-60-90 ratio triangle.
Yes,
So the hypotenuse or PQ is equal to 2A. So
yes.
that therefore QR is just A. So 10 divided by 2 gives us 5. So QR is 5.
Do you see? Without any calculations, we did not use trigonometry, correct? We did not use even the Pythagoras theorem. And we got a result. That is how efficiently we can now solve right triangles. That's the mastery, right? And what is
Mhm.
PR?
Well, again, this is a ratio 30-60-90. And I know that PR is equal to A root 3. So the answer is PR is equal to 5 root 3.
So the answer is 5 root. Beautiful. That is the beauty of what we have learned so far. Priyanshi, how do you find it?
I'm finding it really, really interesting and it's really, really helpful.
Yeah, see, easy. It has become so easy for us, right? So now we have actually solved. Now, if I ask you a question, correct,
Mhm.
that which is a word problem, right? Let's say there is a ladder, right? So that's the ground for us. Great. And let's make a brick wall right there. Okay, so that's the wall for us. Okay,
Mhm.
great. So, and we have a ladder, which is like somewhere here, making an angle of 60 degrees. Perfect. So this ladder makes an angle of 60 degree. We know the length of the ladder. We know this ladder, which is let's say 24 feet. If I have a ladder which is 24 feet long, can you tell me how how high will it go?
Um, is the angle between the wall and the
It's
floor
60
90
degrees. You
degrees?
are right. So what we are saying is that the angle of elevation, this angle is called angle of elevation. Okay, make a new term.
Okay.
You can also say angle of inclination.
What's the difference between inclination and elevation? Or are they the same thing?
Good question. It is as per the application. Okay. Because here it is inclined, right? So we are using
Ah, that's why.
angle of inclination, a term which is same as angle of elevation, right? So I will write both terms, okay?
So if we use it in terms of like, for example, a mountain, we would
Yeah,
use
yeah, yeah,
angle
yeah.
of elevation.
The same term. So it is made with the horizontal. So angle made by the object with the horizontal. So when you see eye angle, so we are talking about that angle of vision, right?
Mhm.
Angle of vision with the horizontal. You get the whole idea?
Yeah.
So let's say that angle is 60 degrees and the length of my ladder is 24 feet maximum. How high can it go? Can you please tell me that?
Well, first of all, we need to know for definite that we're working with a right angle triangle.
Yes,
So,
so walls are supposed to be right angle. So I'll put this.
yeah.
Correct.
Yeah.
Good
So,
question, though. Very good observation. Yes.
um, now we can just use the 30, 60, 90
Yes.
special triangle.
Correct. So what is
Well,
it?
I know if 2A is equal to 24, A
Right.
must be equal to 12.
Right.
And since the height is A root 3, that means the answer to this question is 12 root 3.
12. That's the beauty of special triangle. So it's not that I'm avoiding trigonometry or Pythagoras theorem or anything else. It is I'm using special triangles to solve my problems. And that's how we should be doing if we get 30, 60, 90, or 45 degrees angle, right? There is no need to kill a bird with a cannon. You get the whole idea, right? That's how we'll look into it. You get the idea, right? So
Yeah.
very interesting. Exact value we got right there. So sometimes let me just get back to this picture. So when we write 12 square root 3, we are writing the answer in exact value, right? So this is the exact answer. So I hope you are appreciating what we are showing you here, and that is so many feet. Earlier, we wrote the solution to three significant figures. That was the accuracy, right? And
Yeah.
this time, it is the exact value, right? Much more accurate than what we did last time. Great. And now, let's take another example. And do you, do you ever fly? Do you ever saw kites flying? I know you never used one. Did-
Um, I've used one as well as seen. So
You
yeah.
did? That's
Yeah.
great. Yeah, that's great. Okay, so let's say we have a kite here, right? So I was trying to make one. Okay, so let's say there is a kite here. It should be more colorful. Okay, great. Okay. So we used to have very, less, this is a kite. Okay, great. Now, uh, we'll use the term angle of elevation, okay?
Okay.
So, so, uh, so when we draw these diagrams, I know this is not a mile, so I'm just making a break here, right? So let's say this particular kite is somewhere like that, and we now know how far the kite is along the ground. And let's say this is about 1 kilometer. We are keeping things very simple, okay? So let's say, because the idea is to understand the concept, right?
Yeah.
So this is 1 kilometer or 1,000 meters, right? Which you could also write as 1,000 meters.
Yeah.
And we know this angle of elevation, we're not taking special triangles, but this time it is, let's say, 35 degrees. If the angle of elevation is 35 degrees, can you please tell me how high my kite could be?
Okay. I'm just checking that it's still making like the 90 degrees.
Yes.
Okay. Well, we know our adjacent side and we need to find our opposite side.
You're so right. So, first thing, let's look into SOHCAHTOA once again, right? So,
Hmm.
that is my way of writing, right? Because since they are ratios, right, why not write them uh, giving more meaning, right? So
Yeah.
first thing what we notice here is that uh, we are given two things, which is the opposite side and the adjacent from the angle of our interest, right? So angle 35 degrees. From there, if you look at the situation, we know the height and the distance, which is adjacent side. So we are going to use tangent ratio, right?
Yep.
So, so further on, can you please tell me what this tangent ratio will be? So tan of 35 degrees, correct?
Yeah.
Is
This is
equal to
equal to
pi
uh
over, let's say 1,000. We'll calculate in meters. Is that okay?
isn't tangent equal to opposite over oh yeah,
Right.
yeah. So
Yeah,
yeah, got
correct.
it.
You're right. It is. So you want me to write that also? Okay, let me write down because you are a learner, new person. Okay, very good. So it is opposite over adjacent, and then we will write that the opposite side is h and adjacent is 1,000 meters. So we
Yeah.
are just, splitting 1 kilometer into 1,000 meters. Uh, since we know the height will be much lesser, and we don't want to write decimal answer here, right? So what is height equal to?
Well, it's just tan 35 times 1,000,
Use
which
your
is
calculator. Tell me the answer.
which is equal to 700.208 to through
Seven
decimal.
hundred 700.208. Okay, so I'll just round it to
Yeah, I gave it
700
to
meters,
yeah,
right? Okay, so
yeah.
let me just write 700 meters. So approximate is a good idea to write a dot here and see. So we could now apply what we have learned in trigonometry in real life situation and figure out that, well, the height should be 700 meters. Perfect.
Yeah, perfect.
Now let's continue with this question and also find the length of the thread. So how much thread did I use in this particular flying of kite? So this length L of the thread will be how much? Can you tell me?
Well, we can see that L is actually the hypotenuse of this
Correct.
triangle, and we're aware of two sides.
Correct.
So we can use sine, or we could use cosine.
You're right. But
For
what should
this
you use?
example,
What should you use? See, the opposite side which we calculated is approximate. We calculated. What is
yeah,
given
so
to us is adjacent side.
adjacent
So we should use given side. You got
cosine.
the idea? It's a tip, right? So use what is given to you for accurate answers. See, we are writing answers to three significant figures. Okay. Yes, tell me.
So we should use the given side. That means
Correct.
we should use the adjacent side,
Right.
which means that we use cosine.
You're right. So cos of 35 degrees is equal to adjacent over hypotenuse, which is 1000
Mhm.
over L, the length of the wire thread. So therefore, L is equal to what?
L is therefore equal to 1000 over cos 35.
Can you please calculate?
Yep. I get 1220. I've rounded it, so it's an estimate.
So I'm writing the dot over equal to sign, indicating that my answer is approximated to 1220 meters. Did you understand this question?
Yeah, I got it. It's
Yeah,
pretty clear.
perfect. So we have done two application questions so far. One of them was based on the ladder with special triangle. The other one is with this particular scenario of flying a kite, right? So you can see how easily we can actually apply our learnings of trigonometry and
Hmm.
do real life questions, right? Correct? Great.
Yeah.
So now with this, we'll take one more question. Okay, let's take one more question, right? And that will be the last question for us. Let's say there is a tree, right?
Yeah.
And we'll estimate the height of the tree. So let me just make this tree. So what I do to measure the height, these are all practical things, okay? To measure the height, we walk away from the tree. Okay. So we walk away and we count our steps. And let's say you walk away around 20 steps, right?
Okay.
So I'll calling them as 20 feet, right? Approximately 20 feet. And then we check the angle. For checking the angle, we do have many instruments, right? So we use the instrument to check the angle, and this time we find that this angle is around 65 degrees. The angle is 65 degrees, and this is the height which we want to now find, and we are assuming that this is right angle triangle.
Yeah.
Correct. Now, Priyanshi, tell me, what is the height of this tree?
Well, we can, first of all, I'm going to take 65 degrees as my theta. So
Yes.
um, we need to find the opposite,
Yes,
and we are given the adjacent.
correct.
So I know that tangent uses the opposite and the adjacent. So I can use tan 65, which is equal to h over 20. So therefore, h is equal to tan 65 multiplied by 20. So I'll just work that out using my calculator.
Yeah, sure. Round the figure, tell me the answer.
The answer to that is 43 feet.
So we got an answer of 43 feet as the height of the tree.
Mm-hmm.
Now, Pranshi, I know you did the calculation. Everything should be perfectly fine. Absolutely right. Can you, if you have to check in the test paper, kind of, am I right? Right? Did I use the right ratio? Sometimes
Mhm.
those confusions come to mind, right? Now, can you tell me a method of checking that your answer is actually right?
Um, I could use the
Estimate.
trick. Uh, I was just thinking that I could
Yeah.
have used the ratio. So if I know that I need to have tan 65 as the result, that's just my opposite over my adjacent. So I would actually test it by doing 43 over 20, which would give me my answer, if that
Correct.
makes
I will tell you here from our learnings today how you could approximately check your answer. Well, the
sense.
angle of elevation was 65 degrees, right? If it was 60 degrees, was just slightly less, right?
Yeah, 5 degrees.
Then estimated height will be slightly lower, right? But I know the result, which will be 20 square root 3, correct?
That's right, yeah.
So use calculator. Tell me what is 20 square root 3.
That's equal to 34 point 6410161.
Correct. And therefore, the 743 answer is correct. So what we did was that we kind of estimated, right? For a view 7 degrees more, right? Kind of, right? Seven,
Mm-hmm.
whatever. So we are quite on the right path. So sometimes when the values are close by, we can still use the special triangles to estimate whether we are on the right path or not, right?
Mm-hmm.
It's a very quick way of checking, correct?
Yeah.
Right. So that small 5 degree, I mean, sorry, I just erased it. So that small 5 degree angle difference, do you see how much difference it makes? 6 plus 3,
Yeah.
9 feet of difference. Do you understand? Because
Yeah, that definitely
it's
makes
being
it.
multiplied by a factor of 20. So when you do that, of course, we were expecting 10 feet of difference in this particular case, for sure. Correct. So we are very, very close to our work. You also now understand that how powerful these simple trigonometric ratios are. They can
Yeah.
help you find the height of natural objects, which is so difficult if you think about it. So, just as we found the height of a tree, I could have found the height of a mountain, right? Even the width of a lake without, getting wet from a distance. You get the whole idea.
Yeah.
So, today's lesson with applications we covered, we like to close it right here. And I would like you to now summarize our learnings, right? So, can you please summarize the learnings?
Well, we did a pretty application-based lesson today, but I revised the special triangles, the 30, 60, 90 triangle and the 45-degree triangle. I also learned how trigonometry can be used in real life, such as finding the height of a tree, um, so finding out the height from the ground of a kite, like we did in our question, or basically just like finding
How
distance.
high a ladder can go, right?
Yeah, yeah.
Mhm.
I also learned about the angle of inclination or elevation.
Yes.
They're the same thing, but used in different contexts. So if something is leaning against something, that's when it's the angle of inclination. But if we look at it in terms of a mountain, it's the angle of elevation.
Yes.
So yeah.
Perfect. So, with that, we end our class today. Looking forward for our next lesson where we'll explore more and we'll do three-dimensional trigonometry solving applications in 3D in our next lesson. So, are you excited about it?
I'm very excited. I'm
Great.
having fun.
Great. And then we will check height of mountains and also lakes. Thank you. See you in the next class.
Thank you.